Okay, so today we're going to be starting to learn about light. So fun. Can you see all of that? Anyway, so what light is made out of is photons. We're going to be talking about the particle model. Okay, whoops, whatever. Alright, so for the particle model, light is made of a stream of tiny particles called photons. Alright, so fun. So these photons, what are they made out of? Photons are energy. So they're little packets of energy. Now when we're talking about energy here, they're energy, not mass. So they're just little packs of energy. Little tiny bits of energy that travel very, 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 very fast. How fast do they travel? Very fast. So this is the particle model, because this is the model of light that talks about them being a stream of particles that travel and run into things. So there's a couple behaviors that stem from their behavior as a particle that you are already aware of. The first one is reflection. So light reflects. There's two ways to do it. So light reflects in two ways, generally speaking. There's, of course, a hybridization of these two things, but whatever. The first kind we are going to talk about is diffuse reflection. Okay, so diffuse reflection is going to look like if you have the surface here and you have the light shining into here, it's going to bounce off, but the light going in here is going to bounce off at a different angle. So, and all of these are going to be grouped together very closely. So the light is going to be shining off at all these different points of view. Alright? So this would be similar to if you had a laser pointer and you shined the laser pointer on the wall that's beside you, alright? So the laser, when it hits the wall, is visible from over here, right? So here's an eye. It's should I add eyelashes? Whatever. It's visible from over here because there's light traveling into this eye. It's visible over here because there's light traveling this way too. So there's light visible from every direction, right? Just like if you took a fire hose and you sprayed it against a brick wall, it would just start splashing everywhere. So this is diffuse reflection. This happens on the walls in your room. Now, there is a different kind, the kind that maybe you were expecting from a minute ago, where this kind, the light travels here, and it bounces off. So wonderful. This light travels here, and it bounces off there. And all the light is going to be bouncing off in the same angle. So you're going to have some angle here, and you're going to have the same angle here. So you have an incident angle and a reflection angle. And those two angles are going to be equal to each other. Do you know what this type of reflection is called? This type is called specular reflection. So this is what happens in a mirror, or glass, or shiny metal, or whatever. So the reason why things look different in this type of reflection is because all the light travels in the same angle, so the image is not distorted. Now, what you're saying is, well, the laser beam's not distorted. Well, yes, you are correct. But if you had another laser beam that was right next to it and hit right there, these would overlap with each other and it would get very messy. So that's the difference between diffuse and specular. One reflects at all angles and one reflects only at the same angle that you incident on. Ta-da! So these are your two types of reflection. You can see these happen, in lots of places. You can see both at the same time sometimes. So for example, your friend, your cell phone has reflections. It has diffuse reflection because you can see into it, right, from all different angles. That's why that's diffuse. But specular sometimes occurs if you're outside and then you reflect the light from the sun into your friend's eyes to try to blind them, right? If your friend is standing in the wrong place, if they're standing here, they won't see the sun shining off in the specular. Only if they're standing right there. Okay, so there's another thing besides reflection. It's its friend, refraction. Refraction's a little different. Refraction means that light, no, it's not just light, it's other things too, but we're talking about light. Light bends passing through material. Okay, so, whoops. Alright, so for this is the old pencil in the cup trick. Alright, here you've got a cup. There's water in the cup because that's what cool people do. Now, if you take a laser beam and shine it into here, what's going to happen is it's going to be nice and straight. And once it hits this cup of water, it's going to change angles. Okay, do you see how it cut inwards more? It's more horizontal there. So this angle right here is not equal to this angle right there. Those are different. Okay? Now, you're going to learn more about this later, but we're just doing general behaviors right now. Later as in physics. Now, once it goes out here, it hits another barrier between water and air, so it's going to go do it again in like the reverse thing here. So this angle will be the same, actually. That'll be a 1 and this will be a 2. But these two angles are not like vertical angles, if you remember your geometry at all. So the main behaviors of light are reflection and refraction. Okay, these are what allow it to do lots of things. So we're going to do some practice with that, but we're going to combine it with tomorrow's stuff, so that way we can have a real assignment. But this was your goal for today, to describe these fun behaviors. Oh, hold on, we wanted to talk about why. So why does it do this, right? I mean, for the previous one, that they bounce off. Why does it refract? Because it changes speed. Okay, as the light passes into the water, it slows down. Okay, as it slows down, it gets pulled at an angle, right? So let's pretend you're driving. You've got, 4 tires, 2 on each side. Once this side comes into contact with the cup, it's going to slow down. So let's pretend it's like a car and you go off the road into the dirt and you slow down. Well, this one is going to start to turn until this one also hits, and then you're going to go straight. So that's what's going to happen, is you're going to have an angle there. You're going to turn. And that's the exact same thing what happens to the light. All right? Things slow down when they pass through different materials. The amount is, there's a measurement for that. It's called an index of refraction, right? It's how much it refracts. So the bigger index, the bigger amount it bends, that kind of thing. We're not going to worry about those specifics quite yet. We're just doing some general behavior today. Okay. So there's your behavior for light. We're going to combine this with tomorrow when we talk about colors. Well, I mean waves, but colors too. All right, we'll see you then.